All right, in this video we're going over hyperbolas part 2. Now, hyperbolas, just like ellipses, have focus points. Just like ellipses, there's two foci, and they're either up, down, or left, right, depending on which way your parabola is open. All right. Now, so your focus points inside here. Remember in the first video when I said that they're the set of all points that are the same distance when you subtract the two distances? Well, the focus points is where we were determining those distances from in the last video. Alright? Now, to determine their coordinates, what you're going to do is, if it's horizontal, like in this case, your y values will be the same because they're on the same horizontal line. But your x values will change by a value of c. To get to this one, you subtract. To get to this one, you add. Now, it's the same thing for an up-down, except your x's are going to stay the same and your y's are going to change. All right? Now, your formula to find c, which is the distance from the center point to the foci, all right, is simply c equals the square root of a squared plus b squared. A squared plus b squared. This is a formula you're going to use to find c. For a hyperbola, the c for this is different for the other c. But to find the c for a hyperbola is a squared plus the square root of a squared plus b squared. And that's what you're going to use to find your focus points. Let's work an example. Alright, so we have y minus 1 squared over 9 minus x plus 2 squared over 16. And we want to find the foci. Alright, we want to find the foci. So the first step we got to do, we got to find that center point. Well, -2, +1. Now we need to know what direction we're going. All right, so we need the direction. Well, if you look, y comes first, so our direction is which way? Up, down. Because y comes first, so it mirrors the y-axis, so that means it goes up, down. Now, the next thing we need to do is we need to find c. Alright, we need to find c. Well, remember, this is b squared, so here b equals 3. And this is a squared, so a equals 4. So now we need to do a formula, the square root of a squared plus b squared. So we're going to have the square root of 16 plus 9, which is the square root of 25, which is 5. So c is going to be 5. Alright, c is going to be 5. So now let's find the foci. Foci 1, foci 2. Now, since it's up, down, that means all of our x values are going to be the same thing because they're on the same vertical line. So that means all our x values are -2, just like our center point. Now, to get our y values, we're going to do 1 plus 5 to get 6 for one focus point. And we're going to do 1 minus 5, which is -4, to get the y coordinate of the second focus point. Alright, so to find the foci, not only do you need to find c, but you need to find your center point, and you need to find your direction as well. So for our equation here, again, our center was -2, 1. Our direction was up, down. We found c, which is the square root of 16 plus 9, which is the square root of 25, which equals 5. And since it's up, down, all three of our x values there are going to be the same. So we have -2, -2, -2 for all our x values. And then to get our two y values of our foci, since it's up, down, we're going to do 1 plus 5 to get this one. 1 minus 5 to get that one. And that's pretty much it for finding the foci. Now let's talk about the eccentricity of a hyperbola. They have an eccentricity just like an ellipse does. Alright, so eccentricity, I'm going to label it ECC because you should already have it in your notes and you know how to spell it. It's the measure of how squished the parabola is, just like the ellipse. Okay, it's the measure of how squished it is. And remember, your eccentricity will always be greater than 1. Will always be greater than 1. Alright, so when you get close to 1, it's going to be really, really squished. So here your eccentricity is about 1. Alright, and if your eccentricity is about 2, it's going to be a little wider. Eccentricity of about 3, it's going to get wider still. And anything above that, okay, so they're going to approach straight lines. So this is your, so the bigger your eccentricity gets, the straighter your parabolas become. Alright, if it's 1, they're going to be really, really squished together. And then as you get bigger, they're going to go closer to resembling straight lines. Alright, now your formula is the same thing, C over A or B, but now it's not the bigger one. In this case, it's whichever comes first.
Emily Martin, your ride is waiting. Emily Martin, your ride is waiting.
Alright, so it's C over A or B, whichever comes first. Alright, whichever comes first. So now I'm going to leave the equation for eccentricity up there. Oops, I erased the C. Now, let's look at our previous one. Y minus 1 squared over 9 minus x plus 2 squared over 16 equals 1. So let's look at our previous one. We want to find the eccentricity. Remember, it's C over A or B. Well, we know what C is from the previous problem. We know that C is 5. And in this case, since y comes first, we know that this is b squared, so we know that b equals 3. So that means 3 is going to be the denominator of our eccentricity equation. Because it's A or B, whichever comes first. In this case, B came first. So C is 5, B is 3, 5/3. Alright? That's all there is to eccentricity. Not too bad. Now, on to our last topic for today's video. Asymptotes. That weirdly spelled word. The asymptotes of hyperbolas. Of course, asymptotes are dotted lines which your graph would never cross. Alright, so these are dotted lines that your hyperbola will never, ever cross. And if we used our same equation that we've been using throughout the video, let's find our asymptotes of this equation. Well, to start off with, we need our formula, of course. So your formula is simply y minus k equals plus and minus b over a times x minus h. That's your formula, guys. That'll give you two asymptotes. Alright, so for asymptotes, you will have two of them. They will cross and look like an X in between your two parabolas. Alright? So let's figure out our asymptotes. Well, y minus k. So it's simply y minus 1 equals plus or minus b, which in this case is 3, over a, which in our case is 4, times x plus 2. So you'd solve that for y, which you just add 1 to both sides. So the equations of our asymptotes would be y equals, you add 1, so you could say 1 plus or minus 3/4 times x plus 2. And that's it. That'll give you your two asymptotes. You just simply multiply the 3/4 through. And that's pretty much it, guys. Alright? So now you should know how to find your eccentricity, your focus points, and your asymptotes of your hyperbolas. Alright? And you should know how to simplify this down to actually graph these two lines. Just multiply this through, and then gives you your equation in terms of y, which you can then graph. Alright, so this has been Hyperbolas Part 2. Feel free to watch this video as many times as you need to. And when you come to class tomorrow, be ready to work some problems. See you tomorrow.